Question 25. The frictional force acting on a small block of mass 0.15 kg while it is moving on a horizontal surface has magnitude of 0.12 newtons. The block is set in motion from the point X on the surface with speed 3. It hits a vertical wall at Y on the surface 2 seconds later. The block rebounds from the wall and moves directly towards X, coming to rest at point Z. At the instant the block hits the wall, it loses 0.072 joules of kinetic energy. The velocity of the block in the direction from X to Y is V at time t seconds after it leaves V. Find the value of V when the block arrives at Y and when it leaves Y. Okay, let's do this first. Okay, so there's a block. There's no forward force, 0. There's a backward force, 0.12 newtons. Let's use Newton's second law and find acceleration first. Forward force minus backward force is equals to m times a. A comes out to be minus 0.8 meters per second square. Okay. Now we need the speed of the block when it arrives here first. Okay, so U is 3, V is question mark, A is minus 0.8, and T is 2 seconds. Says 2 seconds later. Okay, let's find V. V square equals U square plus 2AS. V square equals U square plus 2A and S. Right, sorry, we can't use this. We need to use V is equals to U plus AT. So V is equals to 3 minus 0.8 times 2. So V comes out to be 1.4. Okay. This is the speed at Y when the particle reaches Y. Okay. Now we need to find the speed after the particle hits Y and starts to move back. For that, we have to use this loss in kinetic energy. We're told that as the particle hits Y, it loses this much of kinetic energy. Okay, so loss of kinetic energy formula is half and m is common times difference of the speed. Okay, so since there's loss in kinetic energy, that means that this speed is bigger. 1.4 square minus v square is equals to the loss in kinetic energy, this. Okay, now make v the subject over here and get the value of speed at y after the hit. This comes out to be 1. But the answer at the back is minus 1. The reason is initially before the particle hit y, it was moving in this direction. After it hits y, it moves in this direction. So the speed is going to be minus 1 now. Okay. That's done. Now it says that uh, block comes to rest at z. Sketch the velocity time graph. For that, let's do that. Okay. Okay. So we have time here, velocity here. You must write time in seconds and velocity in meters per second. Otherwise, you lose 1 mark for not correct labeling, for not doing correct labeling. Okay, we start from 3 because that's the speed at y and sorry, at x. Then the speed actually decreases and becomes 1.5. So let me make this a bit higher. Okay, so 3 here. Then it drops to 1.4, so somewhere over here, and the time is 2 seconds. So this is 2 and this is 1.4. Okay, now at the very same instant, when it hits the uh, surface, its speed again becomes -1 or 1. This. So at the same instant, you can make a dotted line here and take this to -1, which shows a change in direction. Okay. After that, the speed becomes 0 at z. So we take it back to this spot, and that is it, I believe. I overlooked this. It says that find the value of t when the block comes to rest at z. Okay, so we need to find that. We know from here to here the time taken was 2 seconds, and we need this time as well so that we can add them together for this part. Okay, so at at y, speed is -1, but we're going, sorry, the velocity is -1 on the way back, but we're going to take it as 1. U is 1. V at z is going to be 0. Find acceleration. Acceleration is forward force minus backward force is equals to ma. Forward force is still 0 in this direction. Backward force is still the same, 0.12 newtons is equals to ma. So 0 minus 0.12 is equals to ma. M is also the same, 0.15, and hence you'll get the same acceleration as before. You get -0.8 back. Okay, so acceleration is still -0.8. Okay, now find t from these two. V is equals to u plus at will be used. V is equals to u plus at. V is 0, u is 1, a is -0.8, and find t from here. T comes out to be 1 divided by zero point 0.8, which is 1.25. Add the total time, 2 plus 1.25, we get 3.25 seconds. So we should also show 3.25 here in the graph as well. Okay, next part. Okay, next part says that the displacement of the block from x in the direction from x to y is s meters at time t. Sketch the displacement time graph and show on your graph the values of s and t when the block is at y and when it comes to rest. Okay, first we need all the distances. Okay, find the distance from x to y first. We already know the value of u here, which is 3. We know the time taken is 2. We know the acceleration, that is -0.8. Use these to find s, the distance or displacement from x to y. That would come out to be 4.4. Let's also confirm we can use s is equals to ut plus half at square. So 6 plus zero point 0.5 times minus zero point 0.8 times 2 squared gives 4.4. Yes, we do get this. Okay. Then let's find the distance from y to z. Okay. So at y, on the way back, u became 1, remember? And then at z, v is 0. and acceleration still came out to be minus zero point 0.8, and we need s. So let's use v square equals u square plus 2as. So 0 square is equals to 1 square plus 2 times minus 0 0.8 times s, which comes out to be 1 divided by 2 times zero point 0.8, 0.625. Okay, which means that the displacement from x to z, did they ask for it? The displacement from block x in the direction x to y is s. Sketch the displacement time graph. Okay, so we need we don't really need the value of displacement at z. Had they asked for it, we would calculate it here 4.4 minus 0.625, because the distance from the starting point to y is 4.4, and then we move left for a distance of 0.625 meters, and then this would be the final displacement, which would be the difference. I think it would be needed in the graph, so let's just write it here. So it's 3.775. Okay, now let's draw the graph. Okay, before you draw the graph, you must know a few things. How to convert from speed time or velocity time graph to speed time graph. So to distance time graph. S means distance. This is distance time. Okay. So if a speed time line looks like this, look over here. If there's a falling line here, then the speed time curve looks like, sorry, the distance time curves looks like this. And if it's an increasing line, like from here to here in a speed time graph or a velocity time graph, then the distance time graph goes like this. Okay, so these are two different curves. Okay. And in the speed time graph, if there is a flat line, then the distance time graph goes like this. Okay. Now we're going to use these here. So from the initial point x till y, we know the displacement is 4.4 starting from 0. So initially the displacement was 0. Then it becomes 4.4. This is s, this is t. Must write time in seconds here. Must write displacement in meters here. In meters. Okay. So we start from 0, go till 4.4, and the graph would be a curve like this. Because the speed time graph looked like this, the distance time graph would be a curve like this till 4.4. Okay. Then the displacement drops, and the final displacement was 3.775. Yes, so we will be needing that here. Okay, so bring the graph down to 3.755. Okay, I did not enter the times here. This time is 2, and this time is 3.25. Okay, and the curve would now be like this. Let me try to do a better job here. Okay, this would be the curve. So this is the displacement time graph.